Hello and welcome to another section in further mathematics. Today we'll be talking about calculations with inverse trigonometry. Trigonometric functions. Before we go into doing justice to this topic, I would like us to take a quick review of our last lesson. Okay, thank you. Welcome back. I would like us to do a quick calculation as regards to what we did in our last lesson. Now, one of the things is when you talk about inverse trigonometry function, I told you that it has to do 1 over sine theta, which I said it was known as a cosec theta, 1 over cos theta, I said it was known as sec theta, and 1 over tan theta, I told you is known as cotangent theta, or you call it cot theta. And we did justice in establishing the relationship between each of them. We stated clearly that the value between each of these relationship in our last lesson. Now today we want to go into detailed solving, and our question number 1 goes this way. Let's give our screen a nice shape. We have question says prove that 1 over 1 plus cos theta 1 plus cos theta plus 1 all over 1 minus cos theta is equal to 2 cosec square theta. Now this is a question we have, and before solving you write it very well. Solution. Let's know we are heading somewhere. Now the first thing we need to do is let's solve it and see if we will get this. Now we take the LCM. The first point is LCM of the two denominators, and the LCM becomes 1 plus cos theta, that in bracket I have 1 minus cos theta. That's the LCM. Now you start dividing and perform your multiplication. This divided by this is 1 minus cos theta times 1, so you now have 1 minus cos theta. Put it in bracket, don't forget about your plus sign, and this divided by this, you have 1 plus cos theta. You put it in bracket, 1 plus cos theta. So that is your value here. Now you expand the bracket at the numerator. Let's move to this other side. We now have 1 minus cos theta plus 1, that's this one, then plus cos theta. You discover that we have minus cos theta plus cos theta, so plus minus goes off. The only thing left now is 1 plus 1. So here you have 2 over the denominator is still this one. We do same to this one under. We have 1 plus cos theta, and here we have 1 minus cos theta. So let's do this multiplication. 1 times 1 is 1. 1 times this is minus cos theta, cos theta times this is plus cos theta. This times this is minus cos square theta. So plus cos theta minus cos theta goes off. We now have 1 minus cos square theta. So with that, we are in 2 all over 1 minus cos square theta. But when we did that normal trigonometric function, we stated clearly that sin theta is equals 1 minus cos square theta, since sin theta plus cos theta is this. So if we have this, this becomes 2 over sin square theta. So with this is the same thing, 2 times 1 over sin square theta. And sin square theta, since we have here 1 over sin theta is cosec theta, so 1 over sin square theta will be cosec square theta. So it's the same thing as 2 times, so 1 over sin square theta here becomes cosec square theta. So 2 times cosec square theta is equal to 2 cosec square theta. So you can see that we've gotten to this point. The information was for us to prove that this is equal to this. We started here and we've discovered that what we've been solving is equal to this. So this is the correct answer. So in a nutshell, 1 over 1 plus cos theta plus 1 over 1 minus cos theta is equal to 2 cosec square theta. Now I want us to solve another question. Let's call this number 2. Let's solve one that is a bit stronger. I want us to show that one plus cos theta over 1 minus cos theta plus 1 minus cos theta over 1 plus cos theta is equal to 4 cot square theta plus 2. So we have to still divide our screen when solving. So with this, the first step is taking the LCM, just like what we did in our previous. So the LCM of these two is now 1 minus cos theta and 1 plus cos theta. Because the LCM is this times this, you multiply the denominator by this denominator. So we've done justice to that. So after the multiplication, we start the division. The LCM being these two, divide by this, will give us 1 plus cos theta. And 1 plus cos theta times 1 plus cos theta will give you 1 plus cos theta all square. Plus 1, I don't know if you know how we are doing this. Okay, let me divide 1. 1 minus cos theta and 1 plus cos theta. I say if we divide it like the first one, I divide it by 1 minus cos theta, 1 minus cos theta. So this 1 minus cos theta, 1 minus cos theta, you cancel out. You now have 1 plus cos theta. 1 plus cos theta times 1 plus cos theta is 1 plus cos theta square. You do same here. 1 minus cos theta in bracket 1 plus cos theta. So you now have 1 plus cos theta and 1 minus cos theta. So you now have this plus this. So you now have 1 minus cos theta all square. So which is the same. Now let's go into expanding what we have now. So if you start multiplying this, this is equivalent to 1 plus 2 cos theta plus cos square theta. You know how we expanded this? Let me show you. If you have 1 plus cos theta times 1 plus cos theta, 1 times 1 is 1. 1 times cos theta, you have is cos theta. Cos theta times 1 plus cos theta. Cos theta times cos theta is plus cos square theta. So it's 1 plus cos theta is 2 cos theta, then plus cos square theta. That's how we arrived here. 1 plus 2 cos theta plus cos square theta. You can, that's verification. Now you do same here. You'll be having plus 1 minus 2 cos theta plus cos square theta. Now you also do justice to the denominator by expanding it. If you do this multiplication, you have 1 minus cos square theta. We can just do a rough of it here. You now have 1 times 1 is 1. 1 times cos theta, you have plus cos theta. Minus 1 times cos theta is minus cos theta. Then cos theta times cos theta is, because of the minus sign, minus cos square theta. So cos theta minus cos theta goes off. So we now have 1 minus cos square theta. So that's how we arrived at this 1 minus cos square theta. So let's continue. With this, if you do justice to this point, you discover that you have cos square theta here and you have cos square theta. But if you check what we have, this is 2 cos theta minus 2 cos theta. So cos theta disappears from this. And you have, at the same time, cos square theta. Cos square theta is 2 cos square theta. 1 plus 1, which is 2, all over. And 1 minus cos square theta is sine square theta, which is sine square theta. So with this, what is common between these two is 2. So you bring it out by writing, just bring it out and write 2 in bracket cos square theta plus 1 all over sine square theta. The essence of this is because if you have 2 cos square theta plus 1, if you do 2 times this, will give you this, and 2 times 1, you still get your 2. So this is just an expansion of our previous step. So we move further. Now when you have this, you know this is divided by this, so you now have your expression continues 2. The bracket is now cos square theta over sine square theta plus 1 over sine square theta. You cover it because this sine square theta belongs to both this and this. So I just divided this sine square theta. If you watch, the line is no longer a straight line. That's to say, I divided cos square theta by sine square theta, I divided 1 by sine square theta. So we continue by writing 2 in bracket cos square theta divided by sine square theta is cot square theta. That's the inverse of tan. You know, sine square theta divided by cos square theta is tan theta, tan square theta, and the inverse of tan theta is cot theta. So this is what we have here. And this other side we have plus 1 over sine square theta is cosec square theta. From this point is cosec square theta. But at the same time, when we did cosec square theta in our previous listing, we stated that cosec square theta is 1 plus cot square theta. 1 plus cot square theta. So in having 1 plus cot square theta, we now have 2 here in bracket. Cot square theta plus cot square theta is 2 cot square theta plus 1. Now let's multiply this 2 by everything here. 2 times 2 is 4 cot square theta plus 2 times 1 is 2. So we've gotten 4 cot square theta plus 2. So with this, we've seen that this show that 1 over this 1 over cos theta all over 1 minus cos theta plus 1 minus cos theta over 1 plus cos theta is equal to 4 cot square theta plus 2. And that is what we have here. So our expression and our proof is very correct. So I would like to thank you for joining us in this lesson. In order to refresh your memory on what we've just discussed, please always take out time to solve the test that will be appearing on your screen. And don't forget to make use of this lesson notes in this platform for a better information on the topic we've discussed. Always feel free to drop your questions, your comments, your contributions on the comment section. We'll be very glad to attend to that. Thank you. See you in our next lesson.